The Earth's surface is never fixed. Powerful internal forces and surface processes keep shaping mountains, valleys, volcanoes, plains, earthquakes, and erosion.
Earthquakes, India, and cultural notes. Does India face earthquake risk? Yes, India has had major earthquakes. Past quakes caused thousands of deaths. In a densely populated country, a large earthquake can cause severe damage to life and environment. India lies where the Indian plate pushes against the Eurasian plate, so parts of the country are seismically active and have suffered major earthquakes that killed thousands. Because India is so densely populated, even a single large quake can destroy homes, damage the environment, and cause huge loss of life. Which is why earthquake preparedness matters so much here.
The Gujarat Earthquake 2001. A major earthquake struck Gujarat in 2001. It caused extensive damage, an example of how densely populated regions are especially vulnerable. The 2001 Gujarat Bhuj earthquake is used as a real Indian example. It was extremely destructive, flattening buildings and causing widespread death and damage. It shows how a powerful earthquake striking a crowded region turns into a disaster, underlining the need for earthquake-resistant construction and careful planning.
Don't miss out. Earthquakes in early India. Earthquakes were studied in ancient India as bhukampa, shaking of the earth. In the Brihat Samhita, Varahamihira dedicated a section to earthquakes, noting signs in wind, rain, clouds, animal behavior, and planetary alignments. Ancient Indians observed earthquakes long ago and called them bhukampa, shaking of the earth. In the Brihat Samhita, the scholar Varahamihira devoted a whole section to them, recording possible warning signs such as changes in wind, rain, clouds, animal behavior, and the positions of planets, an early observational tradition in India. In depth, he linked earthquakes to 4 elemental forces: Vayu, wind; Agni, fire; Indra, heaven/thunder; and Varuna, water. An early blend of observation and cosmological reasoning. Weathering and erosion. Why weathering and erosion matter? They continuously break down and reshape the surface. Over long periods, they wear down mountains, carve valleys, form plains, and create caves, cliffs, and river deltas. Having covered internal forces, the chapter now turns to external forces. Weathering and erosion work slowly but non-stop at the surface, breaking rocks down and reshaping the land. Over very long periods, they wear mountains down, carve out valleys, spread out plains, and sculpt features like caves, cliffs, and deltas, creating the smaller, everyday landforms around us.
What is weathering? Weathering breaks rocks into smaller pieces. It happens on the spot. There is no movement of the broken material, only the breaking down. Weathering is the breaking down of rocks into smaller pieces right where they lie. The key point is that weathering involves no movement. The broken material stays put. Only the breaking happens. This is exactly what separates weathering from erosion, which does carry the material away.
Physical weathering. Rocks break by physical stress, caused by temperature changes, frost, or wind that crack rocks into smaller pieces. Physical, mechanical weathering breaks rock apart without changing its chemical makeup. Repeated heating and cooling makes rock expand and contract until it cracks. Water freezing in cracks, frost action, forces them wider. And wind and sharp temperature swings in deserts speed this up. The rock simply crumbles into smaller pieces of the same material.
Chemical weathering. Rock minerals change chemically. Reactions with water, air, or acids create new substances, weakening the rock. In chemical weathering, the minerals inside the rock actually change through reactions with water, air, oxygen, or acids such as acid rain. These reactions form new, weaker substances, so the rock decays and crumbles. The rusting of iron-rich rock and the dissolving of limestone by acidic rainwater are common examples.
Biological weathering. Living things break rocks. Plants, animals, or microorganisms cause it. For example, plant roots grow into cracks and split rocks apart. Weathering also helps form soil. Biological weathering is caused by living things. Plant roots grow into tiny cracks and, as they thicken, split the rock apart. Burrowing animals loosen it, and microorganisms release acids that eat into it. Importantly, all types of weathering together also help create soil, which is essential for plants and farming.
What is erosion? Erosion wears away and moves surface material. Soil, rocks, and materials are carried from one place to another by water, wind, ice, or waves. Unlike weathering, erosion involves movement. Erosion is the wearing away of soil and rock and their transport from one place to another by natural agents, water, wind, ice, or waves. The crucial difference from weathering is movement. Weathering only breaks material down on the spot, while erosion picks it up and carries it away, shaping and reshaping landforms as it goes.
Water erosion. Water wears away land, caused by rivers, rain, or ocean waves. Water erosion is the wearing away of land by moving water. Rivers scouring their beds and banks, rain washing away loose soil, and ocean waves cutting into the coast. It is one of the most powerful and widespread agents of erosion, especially damaging on farmland and along riverbanks.
Wind erosion. Wind carries away loose material, common in dry and sandy areas. Wind erosion happens where strong winds pick up and carry away loose particles of sand and soil. It is most common in dry, sandy places like deserts and semi-arid regions where there is little moisture or vegetation to hold the surface in place, so the wind can lift and move material easily.
Glacial erosion. Moving ice scrapes the land. Glaciers scrape and carry rocks as they move. Glacial erosion is caused by glaciers, huge, slow-moving masses of ice. As a glacier grinds downhill, it scrapes the ground and drags along rocks frozen into its base, acting like sandpaper on the landscape. This carves out distinctive features such as broad, U-shaped valleys in mountain regions.
Coastal erosion. Sea waves wear away the shore. Waves erode land along the coastline. Erosion can both create and destroy features. Coastal erosion is the wearing away of land along the seashore by the constant action of waves. Over time, waves undercut and break up coastal rock, removing material from some spots while depositing it in others. So erosion can both destroy old features, a cliff retreating, and help build new ones, a beach. Erosion and farmers. Erosion removes fertile topsoil. Loss of topsoil needed for crops leads to lower yields for farmers. Erosion is not just a physical process. It directly hits people's livelihoods. For farmers, the greatest harm is the loss of fertile topsoil, the thin, nutrient-rich layer crops depend on. When erosion strips this away, the land becomes far less productive and crop yields fall, threatening both food and income.
Erosion and other livelihoods. Erosion affects many occupations. It washes away land, houses, and roads near rivers/coasts, destabilizes land for construction and mining, and harms tourism and fishing by destroying beaches, rivers, and fertile lands. Beyond farming, erosion affects many occupations. Near rivers and coasts, it can wash away land, houses, and roads, destroying property. In construction and mining, it makes the ground unstable and unsafe. Even tourism and fishing suffer when beaches, rivers, and fertile lands are damaged, showing that erosion shapes not just the land, but human work and economy.
Don't miss out. Ancient water management. The Sindhu-Sarasvati civilization used advanced techniques. They used contouring, bunding, terracing, dams, and canals. Sanskrit texts, Vedas, Krishiparashara, Kautilya's Arthashastra, Vrikshayurveda document these. The Arthashastra even guided land assessment by fertility. This box reminds us that soil and water conservation is not new to India. The Sindhu-Sarasvati Harappan civilization used advanced methods: contouring, bunding, terracing, dams, and canals to manage water and protect soil. Sanskrit texts such as the Vedas, Krishiparashara, Kautilya's Arthashastra, and Vrikshayurveda record these practices, and the Arthashastra even classified land by its fertility.
The Zabo system of Nagaland. An integrated farming approach for soil-water conservation. Earthen bunds on hill slopes plus check dams across streams reduced water velocity, prevented erosion, allowed sediment deposition, and recharged groundwater. The Zabo system of Nagaland is a traditional, integrated way of farming on hill slopes that combines forests, agriculture, and water harvesting. Earthen bunds on the slopes and check dams across small streams slow the flowing water, reduce its speed and force, prevent soil erosion, trap useful sediment, and recharge groundwater. A clever local answer to erosion.
Contouring. Trenches dug along a hillside's contour lines. A continuous contour trench, CCT, slows, holds, and soaks in rainwater, preventing soil erosion and recharging groundwater. Contouring means digging trenches along the natural contour lines, lines of equal height, of a hillside. A continuous contour trench, CCT, catches rainwater as it flows downhill, slows it, holds it, and lets it soak into the ground. This both prevents soil from being washed away and recharges the underground water at the same time.
Bunding. Earthen embankments along contour lines. They slow surface runoff, reduce soil erosion, and increase water infiltration and soil moisture. Bunding uses small earthen embankments, raised banks, built along the contour lines across a slope. These barriers slow down surface runoff so the water cannot rush downhill and carry soil with it. As a result, erosion is reduced and more water soaks in, improving soil moisture for crops.
Terracing. Level steps cut into a hillside. A soil conservation practice that creates a series of level or gently sloping steps to prevent erosion. Terracing turns a steep hillside into a staircase of flat or gently sloping steps. By breaking one long slope into many short level steps, it stops water from gathering speed as it flows down, so soil is not carried away. Terracing is widely used in hilly farming regions to conserve both soil and water. Agents of gradation. What are agents of gradation? Natural forces that level or smooth the surface. They wear down, transport, and deposit material. The main agents are running water, glaciers, wind, waves, and groundwater. Agents of gradation are the natural forces that level the land. They wear material down from higher areas, transport it, and deposit it in lower areas, gradually smoothing the surface over time. The 5 main agents are running water, glaciers, wind, waves, and groundwater, and each creates its own set of landforms.
Running water has an agent. Rivers erode rocks and soil. Running water forms valleys and plains. Running water, rivers and streams, is the most active agent of gradation. As water flows, it erodes rocks and soil, carries the material downstream, and drops it elsewhere. Through this cycle, it carves out valleys in the highlands and builds up flat, fertile plains in the lowlands.
Glaciers as an agent. Glaciers carve valleys. They scrape and carry huge amounts of material, forming U-shaped valleys. Glaciers act like slow, heavy bulldozers made of ice. As they move, they scrape and pluck away huge amounts of rock and carry it far downhill. Their most typical work is widening and deepening old river valleys into broad, steep-sided, U-shaped valleys.
Wind as an agent. Wind shapes deserts. It erodes and deposits sand across dry regions. Wind is the main agent of gradation in deserts and dry regions. It erodes by lifting and blasting away loose sand, and then deposits that sand elsewhere to build features such as dunes. In this way, wind constantly reshapes desert landscapes.
Waves as an agent. Sea waves shape coastlines. They erode coasts to form cliffs, beaches, and bays. Sea waves, helped by currents, are the chief agents along coasts. Their constant pounding erodes the shoreline in some places to form steep cliffs and bays, while depositing sand in others to build beaches. So waves both cut back and build up different parts of the same coast.
Groundwater as an agent. Groundwater dissolves rock. It dissolves rocks like limestone, creating caves and sinkholes. Together, these agents lower high areas and fill up low areas. Groundwater is water that seeps underground. In areas of soluble rock such as limestone, it slowly dissolves the rock by chemical action, hollowing out caves and forming sinkholes. Working together, all 5 agents lower high ground and fill in low ground, gradually evening out the Earth's surface.
Don't miss out. Landforms and human history. Landforms shaped civilizations. Fertile river plains, Ganga, Nile, Brahmaputra, Indus, gave rise to early cities. Mountains like the Himalayas were barriers, yet allowed exchange via passes, Khyber. Deserts, Par, encouraged trade routes, Silk Route. Coasts supported trade and cultural contact. Landforms have shaped human history and civilization. Fertile river plains, Ganga, Nile, Brahmaputra, Indus, provided water and rich soil, so the earliest farming societies and cities grew there. Mountains like the Himalayas acted as protective barriers, yet allowed contact through passes such as the Khyber. Deserts like the Thar limited settlement but encouraged trade routes like the Silk Route. And coasts and natural harbors boosted trade, travel, and cultural exchange.
The Earth has 3 main layers: crust, mantle, and core. The ionothrium rests above the semi-mollient osteorium, where plate movement begins.